Hello everyone. Today we will be seeing the topic called op-amp or operational amplifiers. So the name operational amplifier. So it is an amplifier. So what it does is it will enhance the signal. So or it will increase the signal. That is what amplification is. Or then operational amplifier. Why the name? The operations in mathematics, we know it is addition, subtraction, multiplication, division. Is it? Yeah. So in earlier days, before the coming of this digital circuits and all the operations like these mathematical operations were performed with case of this analog circuits by arranging resistors and capacitors in a certain way. So this op-amp, so operational amplifiers, got the name because from that. It is also called differential amplifier as it amplifies the difference between the two inputs. So in this figure, this is the normal representation of an op-amp. This is the op-amp and we have two inputs V1 and V2, and these the V plus and V minus are the two power supplies. So there can be one power supply also. There are many op-amps with only one power supply. But generally this is also one case, V plus and V minus two power supplies, and V out will be the output. You can see that the output is equal to the difference of the input V minus V2 into the amplification. That is the, we say it as the gain, and we say here it specifically as the open loop gain. Then why it is called open loop? Because see, these two are the inputs, and this is the output. And if this output is fed back as one of the input, then it is called a closed loop. Okay, either this output can be fed as one of the input or it can be fed here as one of the input. So in both cases it is called a closed loop, and the gain will be a closed loop. It is called closed loop gain in that case, but here no such thing is happening. The output is not again going to the input side, so we call it as open loop gain. See, I think it is clear for you. So, and this V1 and V2 I told are the input signals. See, V1 it is written positive here, right? And V2 it is written negative here. Why? This V1 is called the non-inverting input. Means whatever input is given, you will get the corresponding. Suppose you are giving a sine wave here, then you will get a sine wave amplified here without any change, but the amplification, the amplitude will change. Okay, and if we give the same sine wave here, we will get the output an inverted sine wave with an amplification, with the amplitude amplified. So that is the reason why this terminal, whatever input we are giving to this terminal, it will get inverted. That is why this is called the inverting terminal, and it is represented by the negative sign. I hope this much is clear to you. Now see, this is what I told. This input I am grounding the non that one of the inputs, and the V1, this is the positive non-inverting terminal. So I am giving the input only here. So the output will be amplification or the gain factor into V1. So A into V1. And suppose in the next case I am grounding the V1 input, and V2, the inverting terminal is here, this is the inverting terminal. Here I am giving the input. So the output will be an inverted signal. So minus times 8 times, or you can say minus A into V2. Okay, or A times minus V2, whatever it is. And we are connecting the op-amp and giving a common signal here. So the common signal is called VD, and the output will be A times of this input signal VD. And if you see the characteristics of an op-amp, we can see like if the input goes above a certain level, then the output will get saturated. See we that differential input, we are increasing the input, so output is also gradually increasing, and once it reaches a particular point, what happens, it will stop increasing. Instead, no, whatever voltage we are giving, whatever differential voltage we are giving, know that output voltage will be same. It will be same for any voltage we will be giving after this particular point. Okay, that is, it gets saturated. Okay, and there is one more thing we have to remember mainly about op amp for exams and all. That is called the gain bandwidth product. Gain bandwidth product, or the unity gain frequency, which is given by the formula f is equal to this gain bandwidth product, or the unit gain frequency, is equal to the closed loop gain into the cutoff frequency of the op amp. This is for the non-inverting output. This is non-inverting op amp, and for the inverting op amp, this unit gain frequency will be closed loop, the absolute value of this closed loop gain plus 1 into the cutoff frequency. This you have to just remember. We will be doing a video on this with some problems, so just for this you just remember it. We will continue in the next video. These are the basic things about op amp. I hope everything is clear. Thank you.